Hello and welcome back to Math with Mrs. Becker. Today we are looking at Precalculus, Chapter 1, Section 4. We will start studying lines and slopes. So just to start off, a graph is a set of points that are in a plane. And so sometimes these points are connected. Sometimes these points are not connected. When they're connected, you can get shapes such as lines, parabolas, really cool polynomial function shapes. If these points are not connected, you get what is called a scatter plot. And a scatter plot is what we will be studying specifically in Chapter 1, Section 5. Some graphs are based on data points, such as those graphed in Section 1.3. So remember 1.3, we were looking at sequences. Now you can take any sequence and turn the graph into a scatter plot by turning each term from the sequence into an ordered pair, and we will look at that momentarily. When we looked at arithmetic sequence, again, we did graph what are called those scatter plots. Those occur when you do not connect the points. Other graphs arise from equations. So let's see how the two are connected. Here is an arithmetic sequence like we studied in Chapter 1, Section 3. Remember, in order for it to be an arithmetic sequence, going from one term to the next, you need to add or subtract the same number. So let's check this out. To go from a 3 to an 8, I need to add 5 units. To go from an 8 to a 13, I need to add 5 units. To go from a 13 to an 18, I need to add 5 units. Because each time I was adding the same number, that's why this sequence is an arithmetic sequence. Just as a review, how we can graph these. It says graph the sequence as a scatter plot and identify the ordered pairs. So remember my first point, the first term, so the x value is 1 because it's the first. The y value is a 3 because that's the value of the first term. 2, 8, because the second term has a value of 8. 3, 13. The third term has a value of 13. And 4, 18. The fourth term has a value of 18. So when I go ahead and I graph this, we do only need to look at quadrant 1. Remember, when you picture the coordinate plane, there are actually 4 quadrants, 1, 2, 3, and 4. But all of my x's are positive and all of my y's are positive. So that means I'm only going to the right and upwards. So all of my points will land in quadrant 1. These are my x values. I need to be able to go over 4 units. Going upwards, I need to be able to go up to 18. So I'm going to go by 2's. So 2, 4, 6, 8, 10, 12. I'm still going way up here in the words, but that's okay. 14, 16, 18. Now, when I graph a scatter plot, it just means you plot a point at each location. I go to the right 1, up 3. There's a point. I go to the right 2, up 8. There's a point. I go to the right 3, up 13. I go to the right 4 and up 18. Now I do not connect these points. Next thing that we looked at with our arithmetic sequences is we made what's called an explicit formula. Remember, the formula for that is u sub 1 plus n minus 1 times d, where u sub 1 is the first term of the sequence. N is the number of term that we want to identify. So this is the variable that will be inside of our equation. D is the common difference. How are you getting from one term to the next? If you are adding, this will be positive. If you are subtracting, this will be negative. So let's go ahead and figure out a formula for our sequence. Our first term is a 3 plus the group n minus 1. Multiply that by d. D is a positive 5 because I was adding 5 each time. Go ahead and distribute because we do not want to end with parentheses and like terms and all that stuff. We want to simplify this. Remember, when you simplify, there are 2 steps. Always step 1, eliminate parentheses. Step 2, combine like terms. So I have my 3 plus 5 times n is 5n minus 5 times 1 is 5. Now 3 and negative 5, those are like terms. They are both called constants, and what that means is they do not contain a variable. So I can combine those together. I have one term that has an n, so 5n. Positive 3 minus 5 is a negative 2. Now that is called an explicit formula. The reason why it's an explicit formula is because n represents any term that you want to find. If I want to take this sequence and find the 145th term, I can do that. You just replace n with 145. If you want to find the 1,000th term, you can do that. You replace n with 1,000. Now it says graph the explicit formula on the same grid as part A. Now here is the cool thing. This is our little introduction going from sequences to lines. Remember when you graph y equals mx plus b. Okay, this was back, you probably saw this back in 8th grade. You want y by itself, the number in front of your single variable, that is called your slope. If it's positive, it tells you that your line is going upwards. If it's negative, your line is going downwards. If it is a 0, you have a horizontal line. Your b is your y-intercept, which is also your starting point. So if I am going to graph this function, okay, now they want it on the same graph. So I'm going to go down 2, okay, because here, this is where I start. So from the origin, because it's negative, I go down 2. Now my slope, remember slope is rise over run. My slope is 5. I can always take a whole number and turn it into a fraction by putting a 1 underneath. So this is positive, so I go up 5 over 1. Go up, so remember we went by 2. So 2, 4, 5 over 1. Hey, look at that. Up 2 over 1. Do you see where I have the same points? Up 2 over 1. So when I connect it, and this I would connect, ladies and gentlemen, because this is an equation. So this means that together it forms, and in this case, it is a line. Okay, so it does form a shape on a graph. It's not just a scatter plot. If you have ordered pairs, you graph those as separate dots because these are points. If you have an equation or a function, you graph the points and you connect them. So what they want you to realize is you can take these points and you are going to get a scatter plot. But if you turn the terms of the sequence into an explicit formula and graph it with the idea y equals mx plus b, you are going to end up with a line that goes through those points. So stinking cool. They form the same line. Yay. Okay, so there is our little transition. Now we're going to spend some time just really reviewing what the heck a slope is, what it means, and all of those things. So a slope is the steepness of a line. Okay, how steep is it? It describes the change in y over the change in x. Because we're looking at the change in y, remember the y on our coordinate plane, the y-axis runs up and down. So it's the change in y. Is it rising or is it falling? Okay, that's the y value. Over the x runs side to side. Okay, so here is your formula. If you are ever given two ordered pairs, you take the y from the second point minus the y from the first point. That goes over the x from the second point minus the x from the first point. And when you calculate this, your slopes can end up positive, they can end up negative, they can end up being a 0, and they can even end up being undefined. Because what happens here is we are looking at a fraction. Remember, there's that rule that you can never divide by 0. So if you end up with a 0 on the bottom, that slope is said to be undefined. If you have a 0 on the top, that's okay. You can have a 0 on the top. 0 divided by any number is going to be a 0. So let's practice. How do we find the slope of a line? Here's our first order pair, x sub 1, y sub 1. Our second ordered pair, x sub 2, y sub 2. Here's our formula. The second y minus the first y, it's a negative 1, over second x minus first x. Now notice on the top, anytime you minus a negative, that actually changes to plus. So what I really have here is 1 plus 1 over 4 minus 0. On the top, 1 plus 1 is 2. Bottom, 4 minus 0 is 4. 2 over 4 can be reduced to 1/2. So what this means, to get from one point to the next on this line, because it's positive, up 2 to the right, or sorry, up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And you could continue that as long as you want to get as many points on that line as you would need depending on what it is that you're doing. If you're looking at an application, you may need many points. If you are just graphing, it only takes 2 points to make a line. So you'd only need to know the slope to take that y-intercept and change it once. All right, let's try it again. X sub 1, y sub 1, x sub 2, y sub 2. The second y is 1 minus the first y is 1 over second x is negative 3 minus the first x is 4. On the top, 1 minus 1 is 0. Negative 3 minus 4 more is negative 7. 0 over any number is 0. If you have a slope of 0, it means that the line is not going up or down. It is only traveling to the right, so a slope of 0 is a horizontal line. One more time. X sub 1, y sub 1, x sub 2, y sub 2. Second y is negative 3 minus the first y is 5 over second x is 2 minus the first x is negative 2. So on the top, negative 3 minus 5 more gets you to a negative 8. 2 minus a negative 2. Anytime you minus a negative, you're actually adding. 2 plus 2 is 4. Check this out. Negative 8 divided by 4 is a negative 2. So your slope is negative. If you were graphing, you'd want to think of this as negative 2 over 1. Because it's negative, I go down 2 to the right 1, down 2 to the right 1. Let's flip this thing over and see what else we have. So properties of slopes. In the last couple examples, one of the things that we covered is that your slopes can be positive, meaning that they're greater than 0. They can be negative, meaning that they're less than 0. They might be equal to 0, and they can be undefined. If your slope is greater than 0, it rises as you go left to right. And that's really, really important. When you read a graph, you want to read it the same as if you would read a book. You always want to read the graph going left to right. So if your slope is positive, as you look at that graph left to right, your line is going to travel upwards. If m is your slope, if m is less than 0, that means that your graph is going to fall as you go left to right. So again, reading it left to right, if your slope is negative, the line is going to tend to fall, or the y values are getting lower. If m equals 0, m is the slope. If your slope is 0, what you get is a horizontal line. The reason why is because you had a 0 over a number. The top is your rise. How much you're going up or down? Well, it's not going up or down. The number on the bottom tells you how much you're going to the right. So if you have a number here, you're still traveling to the right. It's just not going up or down. M is undefined. What that means is that you have a number on the top and a 0 on the bottom. That's why it's undefined. You cannot divide by 0. In this case, you get a vertical line. The reason why it's vertical is because it's rising or falling, but it's not running to the right. So if you have a graph that has a slope that's undefined, that line would be a vertical line because it never runs to the right, okay? When you are graphing, it is always helpful to have it in that slope-intercept form that I showed you on the front page. Slope-intercept form is y equals mx plus b. Any non-vertical line intersects the y-axis at a point that has 0b. Now, this is the y-axis. The reason why it touches the y-axis is because your x value is 0. you're not going to the right, you're not going to the left. That keeps you on the x-axis. B, if it's positive, you would travel upwards. If it's negative, you would travel downwards. And that's where your graph touches the y-axis. It is called your y-intercept. Because every point on the y-axis has an x-coordinate value of 0, the number B, again, is called the y-intercept of the line. The slope of the line is represented by m. Remember, think of it as rise over run. If it's a positive value, you go upwards. If it's a negative value, you go downwards. But you always run to the right. In order to graph a line from geometry, you should have covered that you need 2 points. 2 points define a line. So here is the next skill that we're going to look at. Find the slope, the y-intercept, and then graph the line. So what we need to do is rearrange this equation so it's in the form y equals mx plus b. So things to notice, the y has to be by itself. Your term that contains the x comes before the constant. So if I want y by itself, check this out. This is a negative y. In order to move it to the other side, I need to add y. Because here I'm adding opposites. They totally cancel each other out. Negative y plus y. What I'd have left is 2x plus 5 equals y. It's okay if your y is on the right or the left. I can now graph this. So my y-intercept, your y-intercept, that is your starting point. That is 5. It's positive 5. So what that means is from the origin, I go up 1, 2, 3, 4, 5. That's where my first point is. Your slope. Your slope is the number that is in front of x. In this case, it's 2 or 2 over 1. Because it's positive, in order to find my second point, I go up 2 units and over 1. You start at your y-intercept, so I start here. I need to go up 2 over 1. There's my 2 points. Connect it. Notice that this line is rising as you go left to right. That's because the slope is positive. Let's look at another one. We want y by itself. So I'm going to take 3x and move it to the other side. The way that we move it is we have to do the inverse operation. This is positive, so I need to minus it here. 4y equals negative 3x plus 8. To get y by itself, I need to get rid of that 4. This is 4 times y, so I need to divide every term by 4 in order to isolate y. Y equals negative 3/4 x. Leave it as a fraction because this is your rise over run. This tells us down 3 to the right, 4. Down 3 to the right, 4. So you want to keep it in fraction form. Plus 8 divided by 4 is 2. Here is your equation. Your y-intercept. Where do you start graphing? Positive 2. Your slope is negative 3/4. So now I can go ahead and I can graph this. So put a few little tick marks. Remember, you only need 2 points to form a line. So if I am starting with my slope or my y-intercept, if I'm starting with my y-intercept, this is positive. So from the origin, I go up 2, and that's my point. My slope, I go down 1, 2, 3, go to the right 1, 2, 3, 4. There are my 2 points. You connect them, form a line. So I'm going to put arrows on the end to show that this is a line. Remember, a line continues forever and ever in both directions. My slope was negative. That's why the line falls as you look at it going left to right. Okay, now here's a more tricky one, but we've got this. If you want y by itself, notice all these crazy parentheses. You need to simplify first. When you are simplifying in math, there are 2 steps. Cancel the parentheses by using the distributive property. Then combine like terms. So that's what we're going to do. 2 times y is 2y minus 2 times 3 is 6 plus. Now there is not a number to distribute here. So this remains just x minus 6. Here I can bring the 4 in. 4 times x is 4x plus 4 times 1 is 4 minus 2. Okay, so I canceled parentheses. Now you go one side at a time and you combine any like terms. I have 2y plus x. Negative 6 combined with a negative 6 is negative 12. Here, I have 4x. I can combine these 2 terms because they're both constants. Positive 4 minus 2 is 2. Now, if I want y by itself, I'm going to minus x to each side and add 12 to each side. So what I'd have left here is 2y. I had a 4x. If I minus 1x, that gives me 3x. I had 2. If I add 12, that gives me 14. Now, to get y by itself, I need to divide everything by 2. So y equals 3/2 x plus 14 divided by 2 is 7. There is your equation in y equals mx plus b form. So your y-intercept, which is also known as b, is a 7. That's our starting point. Your slope, which is often referred to as m, is 3/2. Because this is positive, you go up 3 and to the right 2. So let's go ahead and graph this. So I go up 1, 2, 3, 4, 5, 6, 7. There's my 7, 8, 9, 10. There's 10. 1, 2, 3, 4, 5. Okay, so my first point from the origin is positive 7, so I go up 7. That's where I start. To find your next point, from the starting point, I go up 1, 2, 3, go to the right 1, 2. There's my second point. Connect, draw those arrows. There is your line. My slope is positive. That's why the line rises as I go left to right. Okay. Now, again, they really want to make sure that you understand that with math, there are so many different relationships. So these arithmetic sequences that we have been studying in class are tied directly to linear equations, which is so cool. So let's go ahead and look at that relationship one more time. The first 3 terms of an arithmetic sequence are -2, 3, and 8. Use the explicit form of the sequence to express the nth term. Okay, so we're going to stop right there. They want us to find an explicit formula. So the first term is -2 plus n minus 1 times d. To go from -2 to 3, I'm adding 5. To go from 3 to 8, I'm adding 5. So this is a positive 5. Distribute. So -2 plus 5n minus 5. Combine your like terms. The -2 and the -5 are numbers, so I can combine them. So it's 5n minus 7. That is your explicit formula. N is the number of term in the sequence. Compare it to the slope-intercept form of the equation of the line that passes through the points on the graph of the sequence. To do this, graph both the sequence and the line on the same coordinate plane. So they're having us do kind of the same thing that they had us do at the beginning of the section, just to kind of make a full circle and remind us that it's all together. So if I'm doing the ordered pairs, it's 1, -2, because the first term has a value of -2. The second term has a value of 3, and the third term has a value of 8. So if I am graphing this, 1, 2, 3, 4, 5, 6, 7, I'm going 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. 1, 2, 3, 4, 5, 6, 7, -7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -10. So again, when I'm graphing a sequence, they have scatter plots. Go to the right 1, down 2. There's a point. Go to the right 2, go up 3. There's a point. Go to the right 3, go up 8. There's a point. Now, if I graph this thing, my first point is down 7. 1, 2, 3, 4, 5, 6, 7. Now my slope is 5/1. So I go up 5/1. Up 1, 2, 3, 4, 5/1. Up 1, 2, 3, 4, 5/1. Up 1, 2, 3, 4, 5/1. So when I go ahead and I connect those points, my line goes through the scatter plot. Now today was just a notes day. We will be working on assignment covering this type of information in a couple days. But today, we're just going to go ahead, look at the notes, process the information, no homework for the night. I hope you enjoyed reviewing lines, y equals mx plus b, what the slope is, and tying it into the sequences that we have been studying. Hope you had a great day. I'll talk to you tomorrow.